So, hello everybody, welcome to my YouTube channel, The Learning Hub. In today's video, we are going to discuss about confusion matrix, and we will do the numerical problem for this confusion matrix. So, we will understand confusion matrix in detail. With the help of this video, we will discuss few examples related to that. We will solve the problem examples. We will discuss about sensitivity and specificity. So this is a very important video. So before proceeding further, if you have not subscribed my channel yet, then do subscribe the channel, and also write your valuable solutions in the comment box. So we have already discussed briefly in the previous video about the basics of confusion matrix. That is, as its name suggests, it is a matrix that gives us the output and describes the complete performance of the model. So here we assume that a binary classification problem we consider in which the answer is given as 0 and 1 in the case like spam or not spam. Also we have a classifier which predicts a class for a given input sample. So before proceeding further, let's discuss what does it mean by true positive, for short known as TP, true negative TN, false positive, false negative, which are useful terms in the case. So true positives are the cases in which we predict yes, which are actually yes. Means suppose there is a patient who has been tested for a particular disease, let us say diabetes, and the report shows actually yes, means correct report. So that is true positive. And then we have true negatives. So true negatives are basically the cases in which the disease has been predicted as no and it is actually no. Negative report is there and it has been predicted as negative itself. And false positive are basically the cases, the dangerous ones, that says the case in which we predicted yes but actually it was no. Now this is very dangerous. Just imagine a patient went for a medical diagnosis. Fine. And during the diagnosis, he found to be positive. And their scenario was actually he was negative. So that is wrong prediction has been done as positive. Actually it was negative case. So that is a false positive. Going to be dangerous because the patient will be worried, oh my god, I have got a disease, which is actually not there. Fine. And false negatives, this is again dangerous thing. Now suppose someone is suffering from a chronic disorder or he is suffering from a serious disease or some illness, and in his reports it has been shown that that patient is not suffering from any disease. So in that case patient will go with the very casual approach and he or she will ignore the disease as he is not aware of that. So because this happens, why? Because he was actually having positive but it was predicted as negative. So that is the false negative. The cases in which we predicted no and the actual output is predicted as yes. So from here, which are basically actually no, predicted no. So that is actually no, predicted no, true negative. So and this case actual no, predicted yes. So this is actually no, predicted yes. So false positive. And actually yes, predicted no, that is false negative. Actually yes, predicted yes. So this is true positive. So this is how these values are presented in the confusion matrix. So in this case we have to calculate when accuracy. So accuracy for a matrix can be calculated by taking the average value on the diagonal. So we take like this, that is 50 plus 100 from the diagonal value 50 plus 100 divided by total samples. So we know 150 are the values on the diagonal and the total values were actually including this, that is all the values in the matrix. So that is 50 plus 100 plus 10 plus 5, that is equal to 165. So here what we got? So in this case we got 0.91. So in this case we declared that the model has accuracy 91% as being predicted by the confusion matrix. So let's understand all these things with the help of example. So before proceeding further, let's discuss important terminology of sensitivity and specificity, which are important terminologies to understand. So we know that when developing diagnostic test or evaluating the results, it is important to understand how reliable those tests are, and therefore the results are obtained basically depend upon their correctness. So by using samples of known diseases status, values such as sensitivity and specificity can be calculated that allows its evaluation. And therefore, when evaluating the diagnostic test, it is important to calculate the sensitivity and the specificity of the test to determine its effectiveness. So when we talk of sensitivity, basically this is number of true positive divided by number of true positives plus number of false negatives. So this is how we calculate the terminology of sensitivity. Fine. So basically this is considering the negative values also, but when we talk of specificity, it is considering only the positive values. So we will understand all such things with the help of example. So here we are considering a matrix, confusion matrix for a heart disease, in which it is like this. Here we are having actual values, and in this direction we are having the predicted values. So it says if the patient has heart disease or not, it is actually detected as a heart disease, that is true positive. So the patient has heart disease but it has not been detected, this is considered the case of false negative. So it doesn't have a heart disease but has been detected as a heart disease, so that is false negative in the case. Fine. And it says predicting that the patient doesn't have heart disease and does not have heart disease, it is the true negative case. So let's consider the case of sensitivity, as it shows number of true positives divided by number of true positives plus number of false negatives. This is known as sensitivity, where we are talking of the false negatives also, because number of false negative means they are actually predicted as negative but they were positive. So in terms it is getting the positive itself. So it can be defined as number of total true positives divided by total number of individuals with the illness, because false negative is also the values which should be predicted as positive ones. So this is the case of positivity, which is detected actually as negativity. So this is again, it says the number of individuals with the illness in this case. And specificity is the terminology which says number of true negatives. So it is working on negativity. Sensitivity is working on positivity. Specificity is working on the negativity. So number of true negatives divided by number of true negatives plus number of false positives. Now here false positive mean actually they were negative, because if it is false positive then vice versa of it is true negative. Fine. So how it is saying, it is saying number of true negatives divided by number of true negatives plus actually negatives but being predicted as false positive. Fine. So number it can be defined to number of true negatives total number of individuals without illness. So to sum up, we can say when we are talking of specificity and sensitivity, so sensitivity is working on the parameter of positive and sensitivity is working on the negative, and this plays very important role as a performance measure. So let's solve this example to see how the accuracy of the model can be compared. So here we say, in this example we are considering two examples. One example is consisting of the results of a logistic regression model. So in this case, here we are having results from a logistic regression model where it is saying has a heart disease and has a heart disease. So this is basically true positive. And when we talk of this doesn't have heart disease, and not. So this is we know that actual values, and here the predicted ones. So predicted as negative, not negative is true negative. Fine. So these are the good values that are to be used. And similarly, if we go with this diagram, false positive and false negatives we are getting. So false positive, false negative. Why these are false positive? Because they have heart disease, but actually they don't have heart disease, but predicted as heart disease. So this is a false positive. And it says doesn't have a heart disease, and it says that it is being detecting this device. So this is as false negative. So when we solve this example with this, so let's solve this example. In this we are having these values as true positive, as we have discussed, and these are true negative, false positive and false negative. So let's see, calculate the values for sensitivity and specificity in this case. Fine. So we know that sensitivity works on positive values. So it is true positive divided by true positive plus false false negative, which is actually positive in term. So in this case means which are expected to be. So in this direction we have actual values, and in this direction we have predicted values. So let's put the values in this formula. So it is 139 true positive, that is 139, plus false negative, that is 32. So it comes to be 0.81, which can be added as 81%. Now let's understand what does it mean. It means that sensitivity tells over here that for the results or confusion matrix of logistic regression, so here sensitivity says that 81% of the people who were actually having heart disease were correctly identified as positive itself, because sensitivity we know works on positive. So it says there were 81% patients who were actually positive with the heart disease, and they are actually predicted as positive itself. Fine. So 81% accuracy you can say. Now we can't work only with the positivity, because we have to check whether the negative, how much negative people are actually negative. So for that we work on the specificity. So specificity we know true negative divided by true negative plus the false positives. So what is the value of true negative over here? 112 divided by 112 plus 20. So it is 0.85, that is 85%. So here specificity tells us that 85% of the people without heart disease were correctly identified by the logistic regression. That is 85% are actually having negative cases. So here we see we have not relied only on the problem of positive or negative cases. Like in the previous video we said that when we go with the accuracy only, so the accuracy in that case was defining if the classes having either positive or negative, or there is no proper actually balance between those two, then the accuracy fails in that case. And here when we talk of confusion matrix, this is a better matrix. Why it is better? Because here we can see we are checking for the positive cases as well as for the negative cases also. We are checking for the truthness of the positive as well as for the truthness of the negativity. So this is the best thing that is used. Now remember here we are not concerned about logistic regression or any other type of algorithm. Here we are focusing on sensitivity and specificity. That this confusion matrix may be of logistic regression, it may be of certain decision tree, random forest, or it can be confusion matrix of anything. Our main focus is to check sensitivity and specificity only. Fine. So this thing we have already discussed. Now let's proceed with another example. In this we have taken the results of and random forest algorithm, the confusion matrix with random forest. Now if we calculate sensitivity and specificity in this case, so here the sensitivity is going to come over if we calculate the values like in the previous example we have seen that sensitivity true positive plus true positive divided by false negative. So true positive 142 divided by 142 plus whatever is the values of, like in this case, false negative. So false negative 29, so it comes out to be around the value that is sensitivity over here comes to be 0.83, which is 83%. Similarly for specificity we get 83% same when we calculate the value, like 110 divided by 110 plus 22, it again comes to be 83%. So sensitivity here tells us that the random forest is slightly better if we go with the comparison results. So this is the result for logistic regression and this one is for the random forest. So in case of logistic regression we got sensitivity 81 and specificity 85, and the random forest sensitivity 83 and specificity 83%. So a good balance because it has correct 83% cases accurately identifies as positive, accurately 83% cases has been accurately identifies as negative, whereas there is a variation. 85% for worked correct for negative cases, but for positive cases on the correctness is only 81%. So if we go with this case, from here we can analyze that random forest is slightly better at correctly identifying the positive cases. In this case, the patients with heart disease we have considered. And when we talk of specificity, it tells that logistic regression is slightly better to correctly identify the negatives, which is the case when the patients are talking of heart disease. So specificity works well when we are going with the logistic regression here, that is logistic regression for negative cases, and for positive cases which one has worked well? The random forest. So this is how we can identify or calculate the accuracy of the model. So if we at the end we want to conclude this summary, so here we say sensitivity 81%, specificity 5%. So we choose the logistic regression model if correctly identifying the patients without heart disease was more important than correctly identifying the patients with the heart diseases. Then we go with the logistic regression, because in this case, suppose we want to focus on those patients who were actually negative, who don't have any heart disease, then go with this. Vice versa, if there is positive cases and we want to work on them, then we can go with the other. In that case, positive cases, in that case we can work with the random forest model. So that's all about the confusion matrix, and we have discussed in detail about sensitivity, specificity, how they are playing the role to accurately identify the model's accuracy, and to check which algorithm works in positive or negative cases of the diseases. So if still you have any confusion, then you can write your queries in the chat box. And if you like the video and you have got understanding of confusion matrix, sensitivity, specificity, we have done with the help of very good examples as per my thinking, my observation. So I suggest you to subscribe my channel, because I keep on updating whatever is the new in my channel, and I will also be uploading a few cases of research topics, like currently research areas. I am working on certain research areas, so I will post those also. So for that, you just click on the notification button and subscribe the channel. So thank you and all the best.